Okay, so this one is about the distance that particles travel. Okay, you're talking about net distance, which is, well, let's just define it. Net distance is the distance from your start to your end. Okay, from the start to where it ends. Okay, versus total distance. Okay, where total distance is the sum of all the distances in any direction. Okay, so sum of all the distances the object travels, or the particle, or the bug, or whatever it happens to be, the sum of all the distances moved in any direction. Okay, left or right. Any direction. Okay, so we have the start to the end, which is your net distance. And then we have the sum of all the distances is from the beginning, all the distances to the end. So if we started out at 0, okay, and maybe we went left 3 units, your particle went left 3 units, stopped, and then turned around and went right 5 units, right? The net distance traveled is only 2 units. Because it started at 0 and it ended at 2. Okay, so that would be the net distance traveled. But if we're talking about the total distance, it went 3 units to the left, and then we came back 5 units to the right. So it traveled a total of 8 units in all of its directions. Okay, so net distance is from beginning to end, and total distance is all the distances. So if your particle moves in the same direction the entire time, then the net distance traveled is equal to the total distance traveled. Really easy thing to do, as long as you're going in the same direction. Okay, you could either go to the right and then stop, and then go to the right again and stop, and then go to the right a third time and stop. Right? So it's not about starting and stopping, it's about total distance traveled in one direction. So if that's true, if you're only going in one direction, then your net equals the total. Okay? So to find that, if we're talking about on an interval, okay, on a closed interval from A to B, and remember these are times, from time A to time B, right? Some time distance, some time stamp. The net distance of an object travels can be given to you by a simple absolute value formula. Okay, the position at time A minus the position at time B in absolute value. Okay, in absolute value. Okay, so if your A value is smaller than your B value, then it's a negative, which becomes a positive in absolute value, and vice versa. Okay, so then what about total distance? Okay, so once again from before, if your thing is in one direction, right, if your particle is moving in one direction, then the total distance is equal to the net, which is that same formula, the beginning minus the end, in absolute value. But if on some interval it changes directions, so if on the interval from AB, okay, your particle changes directions, okay, at some other random time C, okay, sometime C between the interval A and B. Okay, so C is between A and B. Then your total distance is found with a sum. Okay, so it's your first distance from A to that point C, okay, where it changed directions, plus the point C to where it ends. Okay, so if we're changing direction, we still have our absolute value to make sure that our distance that we cover is a positive value. Okay, because you can never go a negative distance. It's always positive. So if it changes a couple of times, then there are multiple C values. Right? Maybe there's a D value or an E value on this interval. Okay, so you add them all up, you take their right going distance, you add it to the left going distance, and that is your total distance. So let's practice this net distance and total distance with a formula. So here you have your position formula. Okay, it happens to be a cubic. It looks like a cubic, 2t to the third minus 6t squared plus 8t. Where we're in centimeters. Position is in centimeters. And our time is in seconds. So find the net distance from 1.5 to 4 seconds. So our net distance is the p of 1.5 minus p of 4. So the position at the particle at 1.5 seconds minus the position of the particle at 4. Okay, so we're going to plug these into our formula, right? We're going to replace t with 1.5, and then we're going to replace t with 4, and we're going to get two different values. Okay, so we stick that 1.5 in there, and then our 4, and we get a total, or rather a net distance traveled of 58.75 centimeters. Okay, it's p of 1.5 minus p of 4. So to answer the second part of the question, it asks about the total distance. So in order to know that, we have to see if the particle ever changes direction. Because if it does, then we have more to do. So it's important to understand what's happening when the particle changes direction. Okay, that means that the velocity of your particle equals 0, right? It has to come to a stop in order for it to change direction. So we need to find out when the velocity of your particle will equal 0 and do a sign analysis.
Oh my God, wait, that's up on the total? I don't really know on the total.
Okay, so our function is 2t cubed minus 6t squared plus 8. So that's our position function. 2t cubed minus 6t squared plus 8t. So now we have to take the derivative of that. So the velocity is equal to, this is not v prime, but rather p prime, which is 6t squared minus 12t plus 8. So we want to know when will this equal 0. Okay, so we can simplify this a little bit, right? We can divide all these numbers by 2. That might make it a little bit easier for us to see. So we have ourselves this quadratic. Okay, so I would really love it if this were factorable, because that's the easiest way to solve a quadratic.
So you divided everything by 2?
Divided everything by 2 right here, so I have nothing as a common multiplier, because my brain functions best when I have no common multipliers. So I need to have more numbers that multiply to give me 4, so I could have a 4 and a 1. If I do that, that means I do not have negative 6, where they're both minuses.
Wait, don't you still need a 2 out there?
Okay, so maybe I need to have a 2 and a 2 here. So that would give me a 6. Nope, that's an 8. So it looks like this is not a factorable function. So this is not going to be a factorable quadratic, much to my chagrin. So I need to do the quadratic formula in order to figure out where this is going to stop. So here is a part of your quadratic formula. This is my 6 squared. My 6 squared is 36 minus 4 times a times c. So 3 times 4 is 12 over 2 times a, which is also, well, I guess that's going to be 6. Sorry, it's not 12, but rather 6 on the bottom.
That's nasty.
Okay, so looking in here, this becomes a 48. So 36 minus 48 is negative 12. Okay, so this should be concerning to a lot of you, that I'm taking the square root of a negative. And if you know your algebra 2, this would tell you that our discriminant is less than 0, so we have no real solutions to this, which means it will not actually cross the x-axis. Okay, which is excellent, because that tells us that it doesn't change direction. There is no directional change because there's no 0. The velocity never stops. It never comes to an end. So that can tell us that the net velocity is also equal to the net distance is also equal to the total distance. But without doing this analysis of our velocity, we would not have been able to know that the net and the total distance were the same. Okay, so if it's moving in the same direction, the net is the same as the total.